Good morning. Today we are working on CO58. I can determine whether polygons are congruent, similar, or neither. So we've talked about what polygons are. Okay, we learned that in our last objective. We've talked about what congruent means. Congruent means they are equal. So they are exactly the same. We're going to learn what similar means. So, let's see, congruent polygons are polygons I don't know why this is here. Let's see if I can move that marker out of the way. It's not. Oh, technology. There we go. So polygons that are the same shape and size. All sides and angles are congruent. So here would be an example. If we had A, B, C, and D, and over here I have W, X, Y, and Z. If I tell you that these are congruent polygons, we know that this side, AB, going from the A to the B, so side AB is congruent. That's what the little squiggle line above the equal sign means. They are congruent. So when you draw that, when you see the equal sign with a squiggle, it means it's congruent. It is the same as this side, WX. Okay, so when you see that squiggle line over the equal sign, it means those two sides are congruent. They are the same number. So what line would BC be congruent with? XY. And what would CD be congruent with? If we have CD, we want to look at our other polygon, YZ. So CD is congruent with YZ, and that leaves DA is congruent with which one? ZW. So if I said WZ, ZW, it's the same segment. It can go either way. So those are our corresponding sides. So you should be writing this down. I'm not putting it up here just for my fun. Write down what it looks like to write out your corresponding sides. So AB, and you have the equal sign with the squiggle above it, means it's congruent. So you need to write that. So you should have two shapes here, and they're all labeled like I labeled. Your shapes should have the labels with the A, B, C, D, W, X, Y, Z. And when you draw the equal sign, we're not saying AB is equal to WX, we're saying it's congruent to WX. So we need the squiggle line to show that it is congruent. So that's what congruent polygons are. They're same shape and the same size. So our similar polygons are polygons that are the same shape but different sizes. The angles are congruent. That's how we know it's the same shape. But sides are different. Sides are proportional. So if it is two similar polygons, they're going to look the same. It's just one is shrunk down and one is expanded. But you're doing it proportionately. So when I'll show you an example, I'm just waiting for everybody to write it out. So I'll show you what that means, but think about if you click and drag a shape to get bigger and you're doing it so all the sides grow at the same rate, okay? It's gonna go bigger or smaller, and it's gonna be proportionate. Our angle measurements will all be equal. Are we done writing? So let's see examples of what similar polygons look like. Okay, it says, do the corresponding sides of the polygons make equivalent fractions? If so, the polygons are similar. That means it's proportionate, and we've done proportions already. It was a while ago, but we have to remember how we did those proportions. So here is an example. Let's say I have this triangle, and then I shrink it down. So my side lengths are different, but my angle measurements all match up. So this angle is congruent with this angle is congruent with this angle, and this angle is congruent with this angle. So my angles stay the same. I'm just shrinking it down or making it bigger, but the angles stay the same. So what happens to show they're proportional, we have to really look at how our sides measure up. So this time, when it says list the pairs of corresponding sides, they're corresponding, not congruent. So when I write, oh, I forgot to label them, A, B, C, X, Y, and Z. What?
Yeah, did you times two?
So it is proportionate. So I went down by the same amount on each side. This one with the numbers that we chose, it's easier to see what I'm dividing down by. And some of you have already noticed, oh, you divided by 2 for each one. That's how we know it's proportionate. They all went down by the same number. I divided by 2 for each of them. So when we write it, if we say AB, instead of doing equal sign with the squiggle, we're just going to do the squiggle. That means it's corresponding, it's similar to it, it's proportionate with it. So AB is corresponding with what side? Nora? The XY. BC corresponds, just the squiggle corresponds with what side, Aiden?
YZ.
YZ. And CA corresponds with what side? ZX. I need to make sure that they are proportionate, that they are equivalent fractions. So here's how I'm going to do that. I'm going to take AB over XY, and I want to make sure that equals BC over YZ, and that equals CA over ZX. So to do that, I'm gonna take their side measurements and fill it in for that segment. So where it says AB, what number am I gonna put as my numerator? 8. And that goes over, what's XY? 4. So does that equal BC 14 over 7? Does that equal 18 over 9? Do they equal each other?
Yes.
What is 8 divided by 4? What is 14 divided by 7?
2.
What is 18 divided by 9?
2.
So I know that they are equivalent fractions. They are proportionate. So they are similar polygons. That's how I can prove it. I can say they made equivalent fractions between them. So it was a little confusing at first, but does it make sense now?
Yeah.
All right. So we need to determine whether the polygons are congruent. They're exactly identical. Everything is equal. If they're similar, that it's the same shape, just a different size. It has equivalent fractions for its size, or neither. So I'm going to scroll up so we can see our polygons better. Let's look at this first set. Are they congruent, similar, or neither? Are they congruent?
No.
How do you know they're not congruent? James?
They don't have the same.
They don't have the same measurements.
Same
Yeah. So that's a dead giveaway. They don't have the same measurements. So now I'm going to look, are they similar? Same
Yes.
size, different shape. Sorry, same shape, different size. Are they proportionate? So we don't want to just look at it and say, well, they look to be the same. We need to actually prove it. Okay? So do they look like they're similar? Yeah. So let's see if they actually are similar. So we're going to say, okay, 12 goes over which side over here? 4. 15 goes over which side? The 5. And the 9 goes over which one? The 3. What's 12 divided by 4? 15 divided by 5? 9 divided by 3? So I can see, yes, they are proportionate. Is it always going to be numbers that divide easily?
No.
No. For the examples, we made it easy. So you can see how they're going dividing down by 3 each time. It will not always be that case. And I'm going to show you what I'm talking about in a minute. But for this one, we can see really easily that they are similar. We're multiplying or dividing by the same number for each side. Let's look at our next set. Are those two polygons congruent, similar, or neither? How do you know it's congruent, JT?
It's the same shape and it's just measurements, but it's just flipped upside.
Yeah, it's the same shape and the exact same measurements. It's just flipped
over.
Yeah, even though, well, we just say flipped. You don't have to say over. The technical term is it's flipped. Okay, so even though the shape is flipped, it's still the same shape. So because all of our measurements are the same, we can say it is congruent. So you do have to look, it might be turned, it might be flipped, okay, it's still congruent. All right, we all here together, we're with me on this so far? Let's look at our next page. For some reason on my paper, the directions are split from the bottom to the top, but it says draw and label each pair of figures. Make your figures as accurate as possible. We don't need our protractor or compass to make it exact same angle measurements, but do your best to make them look the same. We're not going to be messy, sloppy, and just draw freehand super quick. If I draw super quick, they don't look alike. Okay? We want them, if they're similar or congruent, we want them to look like they have the same angle measurements. If it's congruent, they have the same size. Okay, so do your best to make it look the same. So you're going to draw two congruent polygons, labeling them so we can see that they're congruent. Draw two similar polygons, putting in the numbers for the sides so we can see that they are proportionate. Multiplying or dividing by that same number for each side. And then for the neither, you're going to draw two different shapes, right? It could be two triangles, but different size, different angle measurements, so they don't look alike. Then it says, determine whether the polygons are congruent, similar, or neither. Explain how you know. Don't trust your eyes. The figures may not be drawn down to scale. So we have to do the math. So here's what this would look like. For this first one, we know it's not what? What do we know right away looking at it that it's not? You said congruent. It's not congruent because our sides are different lengths. So that's just a giveaway. Now we need to say, are they similar? So how do I determine if they're similar? I have to do that math. I have to make my fractions. I'm going to say 12 over 19. Does that equal 11 over 16? And does that equal 9 over 14? So the easy way to do that is to use your calculator. And what does that fraction bar mean? What operation is that fraction bar, Amelia?
Divide.
Dividing. So if I divide 12 divided by 19, I get decimals. If I divide 11 by 16, I should get the exact same decimals. So 11 divided by 16, not the same decimal. So are they similar? No. Because if we divide it down, they should be the exact same number. So we're going to write neither.
Wait, can you put not similar or not?
Nope. It says congruent, similar, or neither. So we always look back at the directions and we want to put what the directions say. Ends up. So let's look at this one. Are they congruent? Yes or no? Why not, Nora? They're different sizes. So we know right away it's not congruent. We need to decide if they are similar. So I'm going to set it up the same way. 6 over 3. Does that equal 8 over 4? Does that equal 6 over 3? Does that equal 8 over 4? So it's not just for triangles. Focusing up here. It's not just for triangles, it's for any polygon. You're always matching up all of those sides. Are they equal? What's 6 divided by 3?
2.
What's 8 divided by 4?
2.
What's 6 divided by 3?
2.
What's 8 divided by 4?
2.
Are these two shapes congruent?
Correct.
Yeah. Does that make sense?
Yes.
That's what you need to do for the bottom ones, and you need to do your review. James?
So if we're down to the top, like doing similar, do you have to label like A, B, C? Do you have to label the letters on the corners of the
We don't have to write out all of that, but you do have to show that the sides, what lengths the
Yeah.
sides are, and put that to be similar or congruent. Stop talking so you can hear the answer to the question, because it's important for you too. Any other questions on today's work? When you finish with today's work, what should you pull out? Olivia? Math packet. It is due next week. Be working on that math packet, coming up, asking me if you have questions. Okay. Math packet work, since I didn't assign Khan Academy this week, you need to be making sure you have that math packet done. We will have a Khan assignment Friday morning. So we will have to split our time between math packet and Khan Academy next week. So work solely on that math packet this week. Get it done early. For my friends at home, we hope you are well, and we hope to see you soon. Have a wonderful day.